All right, in this lesson, we're going to look at another way to solve systems of equations, and this one would be to do it with substitution. With substitution, what you want to look for is you want one of your equations, or both, to be solved for either x or y. So if we look at this top equation on this example, we can see that it's solved for x. By the way, I could take both of these equations right now and get them into y equals mx plus b form, and graph them and see if they intersect that way. That's one thing I could do. Or I could do this substitution, okay? And we'll learn another way too yet, but right now we know those two. So what you want is one of the equations to be solved for either x or y. This one is already solved for x, so I'm just going to go with it. I'm going to circle the opposite side, and then I am going to go to the other equation, and because this is x right here, x and the quantity negative 2 minus 3y are equal to each other. So wherever I see an x, I can replace it with negative 2 minus 3y. You want to make sure, though, that you do that in the opposite equation. Don't try to replace it in the same equation or it won't work, okay? So I go to the opposite equation. I can replace the x with negative 2 minus 3y. So I will do that. So I replaced this x with negative 2 minus 3y, and then I will just continue writing the equation. Now you can see that you have this equation down to one variable. I only have y's in my equation, and so I'm going to solve this equation for y. So to do that, I will distribute the 2 through. So I have negative 4 minus 6y minus 3y equals 5. And if I combine my like terms on the left-hand side there, I have negative 9y, minus 4 equals 5. I can add 4 to both sides, and I will have negative 9y equals 9. Divide by negative 9, and y will be negative 1. A lot of people want to stop right there, but I want you to notice that my original two equations, these two right here, had two variables in them. They had both an x and a y in them, which means you need a solution for both x and y. So I've got the y part of it, and now I will take that, and I'm going to plug the y value back into where I circled, and now solve for x. So x will be negative 2 minus 3, and then instead of this y right here, I can replace that y with negative 1. So x equals negative 2 plus 3, or x equals 1. Then your grand final answer, I want you to write as a coordinate, and I want you to always write it as an x comma y coordinate. So my x is 1 and my y is negative 1 here. And what that means is this: if I were to take those original two equations that I gave you from the beginning, got them both into y equals mx plus b form, and graphed them, they would intersect at the point 1 and negative 1. So in this case, there's one solution to this system. It's the intersection point of 1, negative 1. Okay, this is also another problem that we're going to do with substitution. And so neither of these problems are solved for x or y. I think it would be pretty easy to get this one, the top one, solved for y. So I will do that by adding y to both sides and then subtracting 9 from both sides. Hopefully you can handle that all at one time, so that this top equation becomes y equals 2x minus 9. And the bottom equation I'm not going to change. I will just leave it right here. Again, I can see that I have two linear equations. I could get both of them into y equals mx plus b if I wanted to. I'm not going to take the time to do that. But now this one is solved for y. I will take this equation right here. I will go ahead and plug it in to the opposite equation wherever I see a y. I'm replacing it with y this time because it says y equals on the top equation. Okay, so I go down here and I will replace that y with the quantity 2x minus 9, since they are equal to each other. Okay, I'll go ahead and distribute that negative 3 through. So negative 3 times 2x is negative 6x, and negative 3 times negative 9 is positive 27. And now you can see we have something weird shaking down here. We have 6x minus 6x, which is 0 x's, and so my x's are gone. And now I have this weird thing that's 27 equals 27. So what happened is my variables or my letters disappeared in this case. And sometimes that happens, okay? Your variables could disappear. When that happens, two things could occur. Your letters are gone, and if you have an equation like this, where your two numbers are equal to each other, then you have what's called infinite solutions, which means that these two equations are actually the same line, okay? If I got both of these equations into y equals mx plus b form, they would both, and simplified it, they would both be the equation y equals 2x minus 9, both of them. I'm not going to take the time to do that, but I could turn this bottom equation and simplify it into y equals, get it solved for y, and it would turn into y equals 2x minus 9, which means that they're infinite solutions or the same line. Sometimes you're going to solve it and your variables will disappear, similarly to what they did here, okay? Only you're going to be left with something like 3 equals 4 or 0 equals 5. And what you're left with, even though your variables are gone, is an equation that's not true. And when that happens, when the equation is not true, then you have no solution, which means that they are parallel lines, okay? The only time the two lines will not intersect will be when they are parallel. And so I actually have this here, okay? If you get something like 5 equals 5 after your variables disappear, your answer is infinite solutions, and I'm even going to make you write that this is the same line. And if you get something like 2, 5, then your answer is no solutions, which means your lines are parallel. Okay? And that's it for elimination, or sorry, substitution.